Hello guys, welcome to my channel Jar of Talents. Hope you're all good. So today we are going to look at the chapter Motion. So now if you look at these two kids, one on bicycle and other riding the skateboard, they both are moving. That is, we can say that they are in motion. And if we go to the other side, if you look at this tree is constant. Is it true? No, it's perfectly wrong. Because if you look at this tree is moving with the speed of the wind. You can look at it. So that was the information which we already know. So now let's try to describe motion. Let's do it by considering an example. So let us assume that a school in an village is 2 km north of the railway station. We have specified the position of the school with respect to the railway station. In this example, the railway station is the reference point. We could have also chosen other reference points according to our convenience. Therefore, to describe the position of an object, we need to specify a reference point called the origin. So now let us see what is straight line motion or motion along a straight line. So for making it easier, let us do it by taking an example. So let A, B, C represent the position of the object at different instants. At first, the objects move through C and B and reaches A. Then it moves back along the same path and reaches C through B. The total path length covered by the object is OA plus AC. That is 60 kilometers plus 35 kilometers is, can you say it? Yeah, it's 95 kilometers. This is the distance covered by the object. To describe distance, we need to specify only numerical value and not the direction of motion. There are certain quantities which are described by specifying only their numerical values. The numerical value of a physical quantity is its magnitude. From this example, can you find out the distance of the final position C of the object from the initial position O? Yeah, it's right. This difference will give you the numerical value of the displacement of the object from O to C through A. So now with this we got the definition of displacement, that is the shortest distance measured from the initial to the final position of an object is known as displacement. So now you might be having a question in your mind. Can magnitude of a displacement be equal to the distance traveled by an object? So now let's see the answer. To find the answer, so now let's do that by considering an example. So now have a look at the number line above. For motion of the object from O to A, the distance covered is 60 kilometers. And the magnitude of the displacement is also 60 kilometers. During its motion from O to A and back to B, the distance covered is 60 plus 25. What is it? Yeah, you're always right, 85 kilometers. Well, the magnitude of the displacement is 35 kilometers. Thus, the magnitude of displacement, that is 35 kilometers, is not equal to the path length, which is nothing but 85 kilometers. Further, we will notice that the magnitude of the displacement for a course of motion may be 0, but the corresponding distance covered is not 0. If we consider the object to travel back to O, the final position coincides with the initial position, and therefore the displacement is 0. However, the distance covered in this journey is OA plus AO, that is nothing but 60 kilometers plus 60 kilometers is 120 kilometers. Thus, two different physical quantities, the distance and the displacement, are used to describe the overall motion of an object and to locate its final position with reference to its initial position at a given time. So now let's look at the activities which are present in the textbook of NCERT. So activity 8.1. Discuss whether the walls of your classroom are at rest or in motion. So if we discuss about the walls that are there in our classroom which are in rest or in motion, you can easily say that they are in rest because they don't move from place to place. They are constant. So then we'll look at the second activity, activity 8.2. Have you ever experienced that the train in which you are sitting appears to move while it is at rest? Discuss and share your experience. So it might be happen for many of you guys, and it even happened for me. Actually, when two trains are beside each other on the tracks at the railway station or in moving, when you're sitting in the train which is at rest and when the train beside you starts to move, it feels like that our train is moving, but really our train isn't moving. The train which is beside us is moving. So our object is stationary, but the other object is moving. Hope you understand this activity. So let's look at the activity 8.3 now. Take a meter scale and a long rope. Walk from one corner of a basketball court to its opposite corner along its sides. Measure the distance covered by you and magnitude of the displacement. What difference would you notice between the two in this case? So for this activity says that first we should measure the displacement, that is from one corner of the basketball court to the other corner of the basketball court. Assume that it is somewhat 50 meters. The displacement, as we have seen before, is the shortest distance. And now they have also said to calculate the side. So it would be always more than that of the displacement. So it might be approximately 75 meters. Then activity 8.4. Automobiles are fitted with a device that shows the distance traveled. Such a device is known as odometer, as you guys know. A car is driven from Bhubaneswar to New Delhi. The difference between the final reading and the initial reading of the odometer is 1850 kilometers. Find the magnitude of the displacement between Bhubaneswar and New Delhi by using the road map of India. It is very simple. First, locate the cities Bhubaneswar and New Delhi on India map. Look at the scale before calculating it. Just place a ruler and just check the length and multiply it with the scale and you get the displacement. It's so easy, right? So now let's look at the in-text questions. First question. An object has moved to a distance. Can it have zero displacement? If yes, support your answer with an example. So let's look at the answer for it. Yes, an object moving at a certain distance can have zero total displacement. Do you know why? Displacement refers to the shortest distance between the initial and the final position of the object, as we have seen before. Even if an object moves through a considerable distance, if it is eventually come back to its final position, the corresponding displacement of the object would be zero. So it has been proved. So now let's go to the next question. The second question is, a farmer moves along the boundary of a square field of side 10 meters in 40 seconds. What will be the magnitude of the displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So now if we look at the solution of it, it's a little big, but it's very easy if you understand it. So carefully listen. Given that the farmer covers the entire boundary of the square field in 40 seconds. Total distance traveled by the farmer in 40 seconds is 4 into 10, that is nothing but 40 meters. Therefore, the average distance covered by the farmer in 1 second is 2 minutes and 20 seconds can be written as 140 seconds. because 2 minutes is 120 seconds and 20 minutes, if we add it, it's 140 seconds. The total distance traveled by the farmer in this time frame is, since the farmer is moving along the boundary of the square field, the total number of laps completed by the farmer will be. Now, the total displacement of the farmer depends on the initial position. If the initial position of the farmer is at one corner of the field, the terminal position would be at opposite corner since the field is in square shape. In this case, the total displacement of the farmer will be equal to the length of the diagonal line across the opposite corners of the square. Now, by applying the Pythagoras theorem, the length of the diagonal can be obtained as follows: 14.14 meters. This is the maximum possible displacement of the farmer. If the initial position of the farmer is at the midpoint between two adjacent corners of the square, the net displacement of farmer would be equal to the side of the square, which is 10 meters. This is the minimum displacement. If the farmer starts at a random point round the perimeter of the square, his net displacement after traveling 140 meters will lie between 10 meters and 14.14 meters. As I have said to you before, it's complicated, but if you listen it carefully, you'll understand it. Hope you are understood this problem. So let's go to the third question. Which of the following is true for displacement? A. It cannot be 0. B. Its magnitude is greater than the distance traveled by the object. This question is very simple. So let's look at the solution now. Neither of the statements are true. Hope you agree for it. So now let's see what is the reason for it. Statement A is false because the displacement of an object which travels a certain distance and comes back to its initial position is 0. The statement B is false because the displacement of an object can be equal to but never greater than the distance traveled. Oof, that's it for now. There's been so much that we have learned today, and you might be completely confused now with all this stuff in your brain. So that's it for today, and thanks a lot for watching my video, and please don't forget to subscribe, like and share my channel. See you in my next video. Goodbye.